that they're a little bit smaller than some of the other ones. And that's because, well, we didn't use as much cardboard, and we had a different camera than most people. We had the Fuji cameras, and they didn't have as big of a circuit all by itself, so we just make sure that all the energy's at 10%. Okay, there we go. So that just gives you a little demonstration about how much energy that the capacitor can store. It can store lots and lots and lots of energy over time. And how we do that with this one is we have a little hole at the bottom that we use like a pen or a pencil to press with this. And then you might have heard that sound, and then this little red light should start to turn on.
So where did you get the circuit from?
Well, we got the circuit from a disposable camera, and it's really easy. You just take a screwdriver or other tool, and you can easily just pry it apart, and it should show the circuit. And you can take out the plastic and find this circuit. And the circuit is fairly simple with a couple of transformers in it, but what mainly happens with this coil gun is energy from the battery will travel to this capacitor. The capacitor will continue to store it up, kind of like when you blow up a balloon, bigger, 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 until it gets full, and eventually it will short or break. And some of you might have had that happen to your capacitors. But so we store it up just enough, and then we charge up this button here, and the button allows the capacitor to release its energy. And once the capacitor releases its energy, it's only for a quick split second. And once that split second is over, it will have traveled through the coil. See the red lights going on? That shows you that the capacitor is full. It'll travel through the coil at extremely high speeds, and it'll create...
Do you have a BB in there?
A spark. Oh. No, we don't have a BB.
Oh.
What happens to the BB when it's in there is that it actually is attracted to the center of the coil. And if that reaction didn't happen in a split second, like it does happen with the spark, then it would stay in the center there and just kind of float there, stay there for a few seconds. But since it does happen in a split second and very fast with lots of energy, it has lots of momentum, it carries it very far, and since the centrifugal force of the magnet turns off or deactivates, then it propels it all the way through. So
it's not going to shoot very far, though.
No, it won't shoot very far. You want to shoot the baby? All right. You can put it in.
Oh, no, mine doesn't charge yet.
Oh.
Because of gravity, it pushed it down.
Yeah, gravity's got lots of effect on it, but if it had, you might think to make it stronger, you might think you had to add more coils or larger battery, and the larger battery only adds a little bit of change to it. What really makes it change is the capacitor that stores up the energy and releases it out super fast. And it's the capacitor that allows all this to happen. So, is it charged?
I messed up in the design. But the way that the BB is attracted to the middle section of the barrel is because of the copper cables, which it sends an electric charge, which causes a magnetic pull. And since the BB is metal or copper, it'll have an attraction and it will push it up, like he explained. Was yours charged?
I don't think so.